All right. In this practicum lesson, we are going to play around with types. We start off very easy. We are required to define one variable for each primitive type: number, begint, boolean, and string. Okay, let's get this started. Now, this is not the most exciting. We are required to define variables, not constants. So, let n as type number is equal to 1337, which reads lead in lead speak. Let bi with type begint will be also lead, but with an I. Oh, pardon, with an N, meaning that it's big int. It's not very intuitive why they used N. I mean, usually other languages in the C family are a little bit more consistent, but yeah, whatever. TypeScript has gone a little bit off the deep end. B being a boolean has value true, and finally S being a string has value I am a string. Okay, not very exciting, this exercise. Now, let's break stuff. Cause a compiler error for each variable by trying to assign something to it that is not allowed. Okay, so n is equal to true. Okay, what do we get? We get type boolean is not assignable to type number. Because I'm a bit lazy, I'm going to reuse the same statement and make it fail multiple times. Type boolean is not assignable to type big int. Let's see what happens if we try to assign 1337 to bi. Also not, because type number is not assignable to type big int. B, and in this case we get type number is not assignable to type boolean, and last but not least, type number is not assignable to type string. Okay, now let's perform some type conversions. Number to string. Okay, so S is n dot to string. And as you can imagine, and in case you wanted to see this in action, what happens is very simply I will get string 1337. Now, mind you, also the console is going to give us some hints. Namely, notice that the color is 1337 because we're printing a number the first time, and the second time we're printing a string. Actually, pretty neat and very, very useful. Okay, now string to number with parse int and parse float. Let's put a number here. I don't know, 80.085, and well, obviously this is not really a string, so we get an error, but let's say parse float, and let's parse this value as a float. Hey! Oh, string to number, how silly. Okay, yes, of course. No, my apologies. Let's turn this into a string. I got confused for a second, and let's say that n is parse float of s. And now what do we get? We get 80.085 as a number, and of course if we just print the raw string, we just get, well, you know, the raw string. What happens if we try to parse this as an int? Well, we just get 80. This is also similar to performing another conversion. Well, there are three conversions. So in this case, if we say ceil, we want to get the next number, the next integer number, in case we have a fractional part. So there you go, we get 81 because we round up, we round to the ceiling. And if we say floor, now we want the previous integer number. Now, you might be wondering, okay, and what do we get, for example, okay, for the floor of 80.0, well, that's already at the floor, so that's fine. How about the ceiling? And, well, this might be counterintuitive. You might say, no, the ceiling should still be 81, but in this case, it's just 80. And we also have round as another conversion, so I'm adding some bonus conversions that were not required by the exercise. Round, well, if we're closer to the ceiling, we get the ceiling. If we're closer to the floor, we get the floor. So basically we get the one we're closer to. And in case of 0.5, you might be wondering, well, what about now? What do we get? Do we get the floor? Do we get the ceiling? Because we're in between. Actually, we're not really in between, because so if you look at the tens, now you have 80, 80.1, 80.2, 80.3, 80.4. That's 5 values. Those are collapsed down to the floor. And 5, 6, 7, 8, 9. It's also 5. They're collapsed to the ceiling. And indeed we get 81. So in order to be properly balanced, 80.5 actually has to fall down to the floor. Because 81 is not the ceiling of 80, it's the floor of 81. So we've sort of changed the range. Okay, now, we immediately go to something a little bit more exciting. So we have to define the type of the repeat function that repeats a string, parameter, and types other parameter. Ooh, okay, I like this one. Okay, so repeat, and we have to define the type first and the body after with syntax. Oh, we even get the full definition, because we don't have to define the function itself, but we just have to define the type. Okay, so we have two parameters, and then we get, well, most likely a string back. So what does the type look like? We have two parameters. So many ways to do this. Parameter 1, well, it's clearly the number, because that's n. You can see n suggests it's a number, but then we compare it with 0. We do n minus 1, so it's clearly a number. S, well, we add it. So we do s plus a repeat of n minus 1 s, and that is something we return. So the type of this is the type of s plus the type of repeat, but the type of repeat can also be a string, so s also has to be a string. So the first parameter, I call it _1. Second parameter, I'm calling _2, and I'm stating this returns this returns a string. So when you have this syntax where you have first the type and then the body, what you do get is basically the type as a sort of documentation. This is actually very powerful. You might also say, no, n is a number and s is a string, so I'm repeating the names of the parameters. I'm not like the biggest fan of this, to be honest, but, well, We can also define the type of a repeater as follows. And I can say that repeat is a repeater function. This is also interesting because it allows us to split the type definitions, and it's actually, quite powerful, because by doing this we can also combine these types. So we might have, I don't know, a function that takes as input a repeater, or that returns a repeater, or does something to a repeater, and so having defined the type and giving it a name actually makes our little world of types a lot richer. And one of the most powerful tricks of TypeScript is to really adjust your way of thinking about types as entities that you manipulate explicitly, rather than entities that are still there to make sure that you don't put a boolean into a string. But more about this later. Okay. Ooh, now even more fun. Oh, I wonder, it looks like the person who defined this exercise is really thinks like me. What a surprise. Okay, use the same syntax, but accept the parameters n and s with currying. What is currying? Currying means that instead of taking the parameters at the same time, I take first one, then the other. So this is the function adjusted. Obviously this doesn't match the type. How do I make it match the type? Well, that's how I make it match the type. Of course, the call, because now function repeat takes as input first the number and returns a function that takes as input a string and returns a string. And so to that second function that gets returned, I pass s. Okay. I'm going to anticipate something that you haven't seen already. You could define a function as something that takes as input a generic type that takes as input an A and returns a B. And in this version, the repeater could also be formulated as a function from number, returning a function from string into string. And this all works without having to bother defining the names of the parameters, which I like even more actually, because the names of the parameters only belong here, whereas when dealing with types, which only define structures, we don't care about the names of the parameters. So the names of parameters in types are almost an anti-pattern. I'm not going to exaggerate and say, oh, it's a terrible anti-pattern. No. But it's a minor thing that might signal that your code needs a little bit of rethinking, potentially. And now for the master exercise of today. We are required to define the type in the following declaration. Let me paste the declaration. There we go. We have a car, clearly. Brand is Fiat, model is 500, year is 2022, and the fuel is electric. So, even if you're even if you dislike cars, it's quite a non-controversial car, in some sense. I'm just kidding. Okay, very good. So let's start by defining the type of this little record. Okay, so oh, okay. Let's do something funny. You can put just the value as the type. Now, of course, this is not good because let's make this a variable instead of a constant. Now we've really bound ourselves to exactly those values. Because what I'm stating is that, okay, auto, is a record with keys brand, model, year, and fuel. And the brand may only be Fiat, the model may only be 500, the year may only be 2022, and the fuel may only be electric. So really, that's that's really not okay, because I want to change brand, and now I cannot. There is only Fiat. We could make this. We could open this up. We could say, okay, the brand is either Fiat or BMW or Toyota, and let's say, okay, the models, there's just too many of them, so the model is just a string, the year, well, come on, it's just a number, and the fuel is electric or gasoline. Yeah, okay, who cares, or hybrid or diesel. Let's put now. Yeah, okay, let's leave diesel because it's useful for later. Okay, now if we want to change the brand, you can see that we get proper IntelliSense. But if we want to change the model, let's say a glorious Fiat Brava from the depths of my Italian childhood, well, this is allowed. And we can put whatever model we want. And this kind of makes sense because if you say the brands, there's plenty of brands, but if car brands in your domain are a thing, are a relevant thing, then it makes sense to want to model them properly in order to avoid mistakes. Also because it's sort of a set that doesn't change that often. It's not like a new car brand pops out every 2 hours. Whereas models, there are so many of them that it would be very challenging to define all of them. So yeah, that's it. Now, the next exercise requires us to define a type auto with the type you defined for variable auto. Very good, quite easy. So let's simply take this type, easy refactoring, and there we go. I am wondering now if TypeScript is smart enough to do this. Oh, extract to type alias. Very exciting. Okay, so this assignment is even easier. So there you go. type auto is, and then the body being the type we already had defined. And now let's have a little bit of fun. Okay, now let's decompose this type in with here, with fuel, and use the AND operator to define type auto. Check that you may pass the auto variable to a function that expects with here. Oh, beautiful. Okay, let's see if TypeScript helps us. What? No. Okay, so let's take the year and let's state that we have a type with year which just contains a year. These little fragment types that are building blocks. Now we say, okay, the auto is all of that stuff, and it has a year. And then we also want to state, okay, we have with fuel, and that's another little building block, and there are other things that might have a fuel. So the auto has a Brenner model, but it's also it also has a year, and it also has a fuel. Notice that an error pops up on line 17 because, well, without with fuel, then the fuel key that does not exist, and correctly we get an error from the compiler. Okay, oh, and make sure that fuel may only be electric, gasoline, or diesel with the OR operator. Yeah, fair enough. And if we try to put something else, like fuel is wishful thinking, then no, this is not allowed. You actually need an actual fuel. Okay. And there we go. All right. Now let's have a little bit more fun. And before we actually dive into the next exercise, just a note, it's actually very important to be able to decompose our types. Oh, because we had to check that we can pass auto to with here, which is the core of this way of working with polymorphism. So say we have a function print year, which takes as input, I don't know, an object, and the object has type with year, and then we simply print object. Well, as soon as I press the dot, we're only going to see the keys that are present in with year, which is just the year. And let's say also, oh yes, this is also cute. No, let's do it in a moment. Okay, now let's call print here with auto, and this works. And this kind of polymorphism allows us to define all sorts of functionality related to a simpler type, and we don't have to have all the functions and all the modules of the program depend on the most specific types. So we can define functions that are like print here, that belong to a more abstract, more generic domain with less information, and we could have, you know, the ability to use this function print here also not only for cars but for houses. We could use it for human beings because human beings also have a year of creation, and any object for which it makes sense to create the fact that it was to track the fact that it was created in a given year. We could also say that, well, a car is supposed to have a name, and say that, well, this is not the name, but this is rather the model. So the car, well, has the brand, has the name, and let me adjust here the definition of auto. And now I can say that in order to print here correctly, I want to have I want to be passed an object which has a name and a year, so that I can produce a better message. So object.name is from, and if we were to run this, we get 500 is from 2022. Oh, there you go. And it's interesting now because print here is actually becoming even more articulated. Now print here might even be approaching some level of usefulness that you might encounter in practice, even though admittedly still very contrived example. But yeah, now we're composing two different types with name and with year, and it's nice to see how TypeScript on line 23 is being very smart about determining, okay, it's safe to put the auto, which has quite a lot more structure than just name and year, into print year because it matches all the requirements. So types are a way of defining all of these computational requirements, and when the requirements are met, it's safe to invoke to invoke functions, perform assignments, etc. We can even perform actual assignments, which sort of forget about the full structure. Actually, we are performing an assignment here because object is a variable, and by invoking print here with auto, we are basically assigning auto to object, and this is performing a conversion. But we can see this mechanism even more explicitly in action as follows. So if we have stuff, and stuff is a bunch, an array of things with type with name and with year. So these are a bunch of things that have both a name and a year, and I put auto in here. That's great. And TypeScript doesn't compile. And now if I say, okay, but what about the first element of stuff? What's in it? Oh, there's only name in here. And this is not entirely true. So what the IntelliSense here is always telling us is what is guaranteed to be there. And name and year are certainly there because, well, we declare that stuff, every element of stuff has to be a with name and with year. So yes, there's also a fuel and there's also a brand, but we don't get to see them. And why don't we get to see them? Well, because we might have reassigned the stuff of 0. So we might have said, okay, the name is Giuseppe and the year is 1985, and now you see why TypeScript does not take the risk of being very clever and saying, okay, but still, you know, the first element of stuff is an auto and there's also a fuel or a brand, etc. No, that's not true. That's a risk, and we're not going to do it. Very good. Now, we are supposed to define a road vehicle as either an auto, a scooter, a bicycle, or a truck. Add a kind property that works as a discriminator. Make sure that based on the fuel type, the engine properties are different. Size of engine versus number of batteries. Ooh, okay, exciting. Okay, so okay. Well, let's start by stating that a vehicle basics are a brand, a name, and a year. Okay. Now, then an auto has vehicle basics and a fuel. But a bicycle only has vehicle basics. Oh, okay. Let's have some brands. Let's add some brands of bikes as well, and of trucks. Why not? Okay, I'm not going to bother distinguishing which brands are only for trucks, which brands are only for cars, which brands are only for the bicycles, but we could if we really wanted. So what I'm doing is I've defined a series of very small building blocks of types. I have defined the basic type for a vehicle, which contains the shared components that make up a vehicle. Now I'm assembling the actual types. So the bicycle, and the bicycle doesn't really deviate from the basics. Then we have the car, the auto, which has the basics and a fuel. And we could say, okay, we have the truck, and the truck has the vehicle, basics, and a fuel, and capacity. I don't know if it's the proper word for the truck, to be honest. Capacity. Well, how much freight you can, how much stuff you can put in it. Okay, now a vehicle will be either a bicycle or an auto or a truck. But let's be careful, because we need to have a discriminator. I'm going to put the discriminator. Okay, we could put the discriminator wherever we want actually. I could put the discriminator here. I could say, okay, the kind here is bicycle, and the kind here is auto, and the kind here is truck. But honestly, oh, and notice right away, the kind is auto in this case. Oh yeah, because I stated that auto is an auto. And this is exactly the problem. Like, actually the kind only makes sense when talking about a union, when talking about the vehicle, but not when talking about just the auto itself. Then the kind is relevant, the kind is needed for disambiguation. So let's do this properly. Let's put the kind exactly in the place where we semantically need it in order to, therefore, disambiguate. So now, what am I stating? I'm stating that the vehicle is either a bicycle, and then if it's a bicycle, at the same time, whenever the vehicle is a bicycle, it has kind bicycle. Or it's an auto, and if it is an auto, it also needs the property the property kind with value auto, and otherwise, if it's a truck, it has the property kind truck. And so here I don't need to specify auto. This looks like the syntax. Well, this is an alternative to the syntax where we don't put any smaller types that we then reuse. If we wanted to attempt to do this manually, this is what, by repeating all the fields, which is just terrible. We could have the name, the year, the fuel. I'm not even going to bother the brand. I'm just going to put a string and the kind bicycle, and this will be the bicycle. Otherwise we would have all these things, and the kind is auto, and otherwise we would have all these things, and the kind is truck. And now if you want to add a field to the basics, you have to do it for every variation. So using the type algebra, oh, can I do this? Ah, yes. The fact that you can have the OR operator at the beginning is really an ode to programmers' OCD and to our deep desire to have code aligned. Like, a day in the life of a programmer is so much better when their code aligns properly. Anyway, so if you want to change the name everywhere, you want to add a field, you would have to do it all in all instances. So this is quite ugly, so you should group this out, and if you have smaller components, you should group also those. And actually the cases, so this block before the kind should also be grouped, and you end up with exactly what we had. Okay, now if you want to say that the auto is an auto, well, there you go. But if I want to say my personal vehicle, and I want to state that this is a vehicle, and I try to put auto, it does not work. Why? Because we're missing the kind. And actually, oh, haha, it's interesting though. The error we get is about capacity, because what this is saying is, hey, well, I don't know what it is. It's sort of guessing that it's supposed to be a truck because all the fields are a bit match. But how do we fix this? Well, we provide a kind. So I'm going to make a copy of auto. So this copies all the fields over. And then I'm going to add a kind. And I'm going to state that this is an auto. And oh, lo and behold, line 27 does not cause an error anymore. Okay. Now, let's say that we still want to print here, and we get as input a vehicle. Oh, yes, we can't pass auto anymore, because it's an auto, it's not a vehicle, but if we pass my personal vehicle, then of course everything still works. What do we have here? Well, now we have brand, kind, name in here. We don't have fuel. Why? Because we don't know whether or not the kind is bicycle, and if it is bicycle, then we don't have a fuel, so this is safe. On the other hand, we could check if the kind is different from bicycle, and as you know, inside the then block we now have the fuel, because if it's not a bicycle, then TypeScript is smart enough to see, oh, it's not a bicycle, and all the other alternatives, that would be auto and truck, they do have a fuel, so it's going to be available. Notice that right after the if, and we're back into the land where we don't know whether or not the kind was bicycle, and so we don't have a fuel anymore. Okay, but the name and the year, we do have them. And we could say object.name is from object.year. No, that's it. Okay. Alright, but we are not done, because we want to make sure that based on the field type, the engine properties are different. So we have the size of the engine, or the number of, let's say the number of cylinders and the size of the engine versus the number of batteries, and or let's say the horse, whatever. It doesn't matter. It doesn't matter. I don't need to make this realistic. For now, this is about types in TypeScript. Okay, so with fuel. Okay, let's rename this to with engine. Right click, rename scene with engine. And before anyone comments, oh yeah, but electric bikes may have electric fuel. Yes, I know. It's just, you know, we're trying to keep this TypeScript oriented. But indeed, the ability to model things properly is something that I would absolutely encourage. So if you're watching this and you think, hey, this should be modeled better, by all means, you are encouraged. Also morally required to do so, to model this better. Yes, so please do so. Okay, now with engine, well, we have electric fuel, gasoline and diesel. So guess what we are going to do? We are going to perform the very same decomposition, but now the fuel will be the discriminator. So it's going to do the same, perform the same job as the kind, but we leave it to fuel, because here we actually have a proper name for the kind of fuel. So instead of calling this, because otherwise we could also call this kind, the kind of the engine, which would be fair, but sometimes you don't need to use the kind property. You can use a more semantically accurate property. Okay, so we have an electric engine, and an electric engine has, okay, kilowatts, and number of batteries. Okay, very good. And then we have a combustion engine, and it has horsepower and number of cylinders. And well, there we go. Now with engine will either be an electric engine or a combustion engine, but again, now we add a discriminator because the electric engine will have a fuel which is electricity, and the combustion engine will have as fuel gasoline or diesel. And here I'm actually doing something that's pretty neat, because with engine is now stating that, yeah, okay, so the electric engine has fuel electricity, that's the discriminator, but the discriminator for combustion engine is actually double, and TypeScript is really smart enough to save us from having to repeat. Let me show you the fuel twice. So this is not needed. I can just group it together and it just works. Okay, so the vehicle basics, okay, very good. Okay, oh, I changed the fuel, now it's called electricity. Oh, now something is still missing. Why? Well, because we're missing, look. The type is missing kilowatt and number of batteries from type electric engine, because now it knows that we have specified the discriminator for the fuel. And so what we are missing are the rest of the properties from, yeah, no, that's probably unrealistic. I have no clue. I honestly have no clue. I'm hoping this is enough, or whatever. And the number of batteries will be, I also have no clue here. So let's say that there's 500 little batteries. Okay, there we go. And now, but you can see actually that there's this selection and refinement process that the IntelliSense is also helping you with. So if the fuel had been gasoline, well, let's do it. Now, okay, we get an error on kilowatt and number of batteries, and here on auto we now get an error stating that we're missing the horsepower and the number of cylinders. So the horsepower is going to be, I think, not even 100 for the Fiat 500. And the number of cylinders, I'm going to guess it's a little 3-cylinder engine. Okay, and there you go. Now, define a print function that shows a card with information about the vehicle by checking the kind of vehicle and the fuel in order to print all the right fields. Okay, now print vehicle. I'm not going to do all of this, I just want to show mostly the principle. Now, or I will do it partially at least. Okay, so we have to check the kind now, because if it's a bicycle, that's it, that's all we're supposed to print. But then we say if the kind is different from bicycle, then now I can print more stuff. I can print the fuel. But in order to print the fuel, I actually have to check. And now I get the fuel in here, and now I have to check what kind of fuel this is. So if it's electricity, console.log, it runs on electricity and has, and I really should get the habit of always using the back quotes, and has object dot fuel, oh, object dot kilowatt. Else, and because diesel and gasoline actually contain the same properties, then we don't need to further refine. We can say, okay, it runs on object dot fuel, because this is going to be diesel or gasoline, and has so much horsepower. If we run this, we get the full print. 500 is from 2022, it runs on gasoline and has 95 horsepower. And my trusted bike will be, okay, now let's start with the kind, bicycle, and then the brand will be, oh yeah, by the way, Urban Arrow is only electric bicycles, so there you go, we should model this better. The name is black, the black variant, I don't know. Then what else? We have the year, say 2019, and oh, okay, now the bicycle is done. Very good. So if I want to print my trusted bike, now the whole bit. Oh, black is from 2019, so let's also add the brand. Oh, Fiat 500 is from 2022, it runs on gasoline and has 95 horsepower. Urban Arrow Black is from 2019. Okay, very good. I am actually quite bothered by the fact that the Urban Arrow is not electric in our example, because it really should be. So, okay. Okay, so let's say that yeah, it's really bothering me. So an electric bicycle has vehicle basics and just an electric engine. This is very cute, isn't it? Because I don't need the fuel. Well, okay, it's really up to us whether or not we want the electric bicycle to have the. Yeah, it probably makes sense, you know, to have the electric engine and the discriminator. But we could say the fuel electricity is so implicit that we don't want it. I don't know. It depends on whether or not we use the fuel. But I guess it's probably a better idea. Okay, anyway, and now the vehicle will be, and let's use the wonderful power of unions also to have an electric bicycle and have another kind. And now my trusted bike will be an e-bicycle, and now I have to specify more things. Now notice that here the fuel is electricity, even though I stated that this is a vehicle, so in principle it could be anything. By stating that the kind is e-bicycle, then we know, okay, the fuel can only be electricity. And what else do we need? We need a kilowatt, no idea, and we need, wait a second. Oh, yes. And the number of batteries will be, I don't know, 12. Oh, it's missing a comma. Oh, I was wondering, wow, what happened all of a sudden? No, nothing. Okay, and now the Urban Arrow runs on electricity and has 500 kilowatts. Very good. I have no idea if it has 500 kilowatts. I really don't have an intuition for this. I'm still relatively new to the world of electric stuff. I've never really asked the question, what do these numbers mean? But for electric vehicles. All right, and we have it. Yeah, we might have done something very extreme here. So for the electric bicycle, we might have done this. And this is exactly the same as the previous definition, but it's stating that basically I want to have for the electric bicycle everything that's in vehicle basics, and then it has an engine where the fuel is always electricity. So this end forces the fuel not to be gasoline or diesel. So yeah, this is kind of a classy variation which promotes code reusability and has less repetition, but I'm not telling you that this is the best way to do it. It's a way and it's a good one, but the best, I don't know. That's really subjective. Okay, now I do understand that this is This might come over as a challenging exercise, and it is in a sense, because this is not about little types A, B, and C. This is about designing a solution to a problem, and this requires a mix of modeling and understanding of types and understanding of, at this point, intermediate and in some cases even advanced constructs in the type. This sort of thing is difficult because it requires you not only to struggle with the language, and if you're a beginner you might be struggling with the language, but also to make room in your brain for the domain you're modeling, like in our case, you know, cars, batteries, fuels, etc. And this is difficult. It's what programming is about. Do not be discouraged, and do remember, the master has failed more times than the beginner has even attempted. So it's really all about playing around, exercising, rewatching the lectures, and you will be there in no time. Thank you very much, and see you soon.